Hello everyone, I'm Teacher Neth, and welcome back to our general math class. In this lesson, you'll know better the characteristics or features of an exponential function and its different representations, visual, in symbols, and even in tabular form.
Example 1. Sketch and compare the graphs of f of x equals 2 to the x and f of x equals 3 to the x. Since there are two exponential functions involved in example 1, then we will prepare two table of values. The first table of value will be for f of x equals 2 to the x. In this table, the first row refers to the x values. I assign 7 numbers to x, and I consider the numbers from -3 to +3, although you may assign any set of numbers to x, and they may be greater than 7 or less than 7. And then the second row is the set of y values, the corresponding y values. You will just substitute each of the x values to the x, the exponent x, and then the value of 2 to the x will be the value of y. That is, if x is -3, then y is 2 to the -3. And we know that 2 to the -3 is also equal to 1 over 2 cubed. 1 over 2 cubed is equal to 1/8. And so on. Then the second table of values will be for the second equation, for f of x equals 3 to the x. Again, the first row is the set of x values. You'll assign x values. And then the second row is the set of y values. So again, you will substitute each of the x values to x in the equation, and then the value of 3 to the x will be the value of y. Again, if x is -3, y is 3 to the -3, or 1 over 3 cubed, or 1 over 27, and so on. Now that we have the table of values for both equations, and we are asked to sketch their graphs and compare, so let us proceed to the next slide for the graphs of these equations. After plotting each set of points from the tables of values in example 1, and then by joining each set with a curve, this is what we will form. The green curve is the graph of f of x equals 2 to the x, while the purple curve is the graph of f of x equals 3 to the x. Notice that both equations are written in the form f of x equals b to the x. Here, b is equal to 2, and in the second equation, b is equal to 3. Both are greater than 1. Given that b is greater than 1, the properties of the graph of f of x equals b to the x are the following. First, it is increasing. It can be observed from both curves. Both are increasing. That is, as x increase, y also increase. Second property is, as b increases, the graph gets steeper. Notice that the purple curve is steeper than the green curve because the value of b in purple is greater than the value of b here. This is 2, while in the purple curve, the value of b is 3. So as b increases, the graph gets steeper. So we may expect that the curve of f of x equals 4 to the x is even steeper than the purple curve. Third property, y equals 0 is an asymptote. If we zoom this in, you will notice that both graphs will not touch the x-axis. The x-axis is y equals 0. The equation of that line is y equals 0. Y equals 0 acts or functions as the asymptote of the graph of f of x equals b to the x when b is greater than 1. So that means as x decreases, the value of y decreases, but it will never reach 0. So y equals 0 is an asymptote. Next property is y-intercept is equal to 1. Notice that both curves touched the y-axis at 0, 1. So the y-intercept is always equal to 1. Next property, the domain is the set of real numbers. The domain is the set of x values, possible x values. Notice that x may take any number. This may continue to decrease, x, and then x may continue to increase. So x may take any number, so the domain is the set of real numbers. The range is a set of positive real numbers. Range refers to the set of possible y values in the equation. Notice that since the graph continues to increase, then y may take any value. However, there is a restriction in the y values. Y cannot be 0, so it also cannot be a negative number. It just gets nearer and nearer to 0 as x decreases, but it will never be equal to 0, nor any negative number. So the range is only the set of positive real numbers. It also passes both vertical and horizontal line tests. So when you draw any vertical line on any part of it, it will intersect each of these graphs, of course, at one point only. And if you draw a horizontal line on any part of the graph, it will touch the graph at one point only. Example 2. Sketch and compare the graphs of f of x equals 2 to the x and f of x equals 2 to the negative x, or f of x equals 1/2 to the x power. Like in example 1, there are two exponential functions involved in example 2. So we will prepare two table of values to sketch and to compare the graphs. Again, the first table of values will be for f of x equals 2 to the x. And then the second table of values will be for the second equation. 2 to the negative x is also the same as 1/2 to the x. You'll arrive at the same y values. So again, I substituted or I assigned values to x, and then you substitute each of the x values to this x exponent to get the corresponding y value. For example, if x is negative 2, then this will be 1/2 raised to the negative 2. And as we all know, for that to be positive, a positive exponent, we just get the reciprocal of this. So that will become 2 squared instead of 1/2 to the negative 2. So 2 squared is equal to 4. Look at the y values. Notice that they are just reversed. This is from 1/8 to 8. This time in the second table of values, it becomes 8 to 1/8. Let us see how this will affect the graphs of the given equations in the next slide. After plotting each set of points in example 2, you'll form these two curves. The green curve is the graph of f of x equals 2 to the x, and the purple curve is the graph of f of x equals 2 to the negative x, or f of x equals 1/2 to the x. Notice that the two equations are similar in the sense that both b are 2, so their b's are equal. However, they are not, or they are different in the sense that one exponent is negative and the other is positive. And this is how it will affect the graph. Notice also that 2 to the negative x is the same as 1/2 to the x. The exponent is positive, however, the value of b is not greater than 1. Rather, it is less than 1, an improper fraction. Given that b is between 0 and 1, a fraction, the properties of the graph of f of x equals b to the x are the following. First, it is decreasing. We observe that in the purple graph. As x increase, y decrease. So it is decreasing. So that is the difference between the graph of 2 to the x, f of x equals 2 to the x, and f of x equals 2 to the negative x. When you make the exponent negative, it becomes a decreasing function. Next property, The graph is symmetric to f of x equals b to the negative x with respect to the y-axis. Notice that these two are symmetric to each other with respect to the y-axis. So if b are the same and their exponents have different signs, they are symmetric with respect to the y-axis. Third property, y equals 0 again is an asymptote. So if we zoom this in, you will notice that the curves get closer and closer to y equals 0 or the x-axis. Also this purple curve, this gets closer and closer to the x-axis, but each of them will never intersect the x-axis or the graph of y equals 0. So that is an asymptote. Fourth property, the y-intercept is equal to 1. Again, both curves or both graphs touches or passes through the y-axis at 1, at 0, 1. The domain is the set of real numbers. Domain is the set of x values, and any x value may be taken by the exponent in an exponential function. So the domain is the set of real numbers. There is no restriction in the values of x. However, for the range or the y values, it is a set of positive real numbers. It does not touch the x-axis, so it cannot be equal to 0, and it also cannot be equal to any negative number for y. So the range is the set of positive real numbers. And it passes both vertical and horizontal line tests. Considering each of the graphs, when you draw a horizontal line or a vertical line on any part of the graph, each of these line tests will intersect the graph of an exponential function at one point only. Example 3. Sketch and compare the graphs of f of x equals 2 to the x and f of x equals negative 2 to the x. So what's the difference between these two equations? One is positive 1 multiplied by 2 to the x. The other is negative 1 multiplied by 2 to the x. So both these are still equal to positive 2. However, one is multiplied by negative 1 and the other is multiplied by positive 1. So first, we will prepare table of values for each. This is the table of values for f of x equals 2 to the x. And the second is the table of values for f of x equals negative 2 to the x. So that is, after substituting the x value to the exponent, 2 to the negative 3, that is 1 over 2 cubed or 1/8, you multiply it by negative 1. So that will become negative 1/8. Let's take, for example, a positive number. For example, x is positive 2. So this will become negative 2 squared. What is raised to 2, to exponent 2? Only positive 2. So that will be 2 squared is 4. Positive 4 times negative 1 is negative 4. So in short, each of these y values will just be negative. From positive, they will be negative. Now, how will that affect their graphs? Let us look at the next slide. So these are the graphs of the two equations. The green curve is the graph of f of x equals 2 to the x, and the purple curve is the graph of f of x equals negative 2 to the x. B here is positive 2. B here is positive 2. However, the value of a here, a factor, a multiplier of b to the x, is 1, positive 1. Here, the value of a is negative 1. So, how does a affect the graph of an exponential function? Given that a is negative, like in purple equation, or a is less than 0, the properties of the graph of f of x equals a times b to the x are the following. First, it is decreasing. As x increase, y decrease. So it is decreasing. Second, it is symmetric to f of x equals a times b to the x with respect to x-axis, where a here is positive. So their graphs are symmetric with respect to the x-axis. Next, y equals 0 is an asymptote. Again, each of the graph of an exponential function gets closer and closer to the graph of y equals 0 or the x-axis, but it will never touch the x-axis. So y equals 0 or the x-axis functions as an asymptote. Fourth, the y-intercept is negative 1. If the y-intercept of the green curve, that is when a is positive 1, the y-intercept of this equation where a is negative 1. Fifth, the domain is the set of real numbers. So the value of a does not affect the domain. Still, x may take any value in an exponential function. For the set of y values or range, it is a set of negative real numbers. So y may take any negative number, negative value, but it can never be 0 or any positive number. It just gets closer and closer to 0, or it only approaches 0, but it will never be 0. And the graph also passes both the vertical and horizontal line tests. When you draw a horizontal line on any part of this graph, it will intersect the graph at one point only. Also, the same is true with the vertical line. Draw a vertical line on any part of the graph. They will meet at one point only. Example 4. Sketch and compare the graphs of f of x equals 2 to the x, f of x equals 1/2 times 2 to the x, and f of x equals 2 times 2 to the x. So for the first time, we will consider 3 equations or 3 exponential functions. All b's are equal to 2, but they differ in a values. In the first equation, the value of a is positive 1. For the second, it's 1/2. For the third, it's positive 2. So we'll prepare 3 table of values. The first is for f of x equals 2 to the x. The second is for f of x equals 1/2 times 2 to the x. So the shortcut there is to multiply each 2 to the x by 1/2. So that is 1/8 times 1/2 is 1/16. 1/4 times 1/2 is 1/8, and so on. And then the third table of values will be for f of x equals 2 times 2 to the x. Again, we may just multiply each 2 to the x by 2. So 1/8 times 2 is 1/4. 1/4 times 2 is 1/2, and so on. Let us see how values of a will affect the graph of an exponential function. So these are the graphs of the 3 equations in example 4. The blue curve is the graph of f of x equals 2 times 2 to the x. That is where a is equal to 2. The green curve is the graph of the equation with a equals 1. And the purple graph is the equation when a is equal to 1/2. What are the properties of the graph of f of x equals a times b to the x? First, it is increasing if a is greater than 0. Since all a's here are greater than 0, 1, 2, and 1/2, then the graph is increasing or are all increasing. However, if a happens to be negative, a negative number, then the graph will be decreasing. And we have observed that already in the previous example. then y equals 0 is an asymptote. So if we consider each equation or each graph, you will notice that they approaches 0 but they will never touch or reach 0. They will never touch the x-axis. So since the equation of the x-axis is y equals 0, then this is what is meant by y equals 0 is an asymptote. Third, y-intercept is equal to a. So whatever the value of a is, that will be the y-intercept, or the graph will touch the y-axis at that point. If a is equal to 2, then the y-intercept is 2. If y is equal to 1, then the y-intercept is 1. And if a is equal to 1/2, then the y-intercept or the graph will touch y-axis at 1/2. Fourth, the domain is the set of real numbers. Notice that the graph may continue to increase, will continue to increase, and will continue to decrease in the left side. So x may take any value, so the set of x values or domain is the set of real numbers. The range of the set of y values is the set of positive real numbers if a is greater than 0, and is the set of negative real numbers if a is less than 0. So in this particular example, all a's are greater than 0. That's why the y values or the range takes only positive real numbers. If a happens to be negative, just like in the previous example, then you will notice that the y values takes only negative real numbers. Sixth, the graph is a vertically shrinked version of the graph of f of x equals b to the x if a is less than 1. Which of these three has a is less than 1? The purple curve, because a here is 1/2, that's less than 1. If a is less than 1, the graph is a vertically shrink version of the graph of f of x equals b to the x. That's when a is equal to 1. So the purple curve is the vertically shrink version of the green curve. So from 1, the y-intercept becomes 1/2. From 1, 2, the graph or the point becomes 1, 1. From 2, 4, it becomes 2, 2. So it is vertically shrinked. However, it is a vertically stretched version of the graph of f of x equals b to the x if a is greater than 1. Just like the graph of f of x equals 2 times 2 to the x, where a is greater than 1. It is 2. It is a vertically stretched version of the green curve. From 0, 1, the point becomes 0, 2. From 1, 2, the corresponding point becomes 1, 4, and so on. And each of the graphs passes both vertical and horizontal line tests. Example 5. Sketch and compare the graphs of f of x equals 2 to the x, f of x equals 2 to the x minus 1, and f of x equals 2 to the x plus 1. This time, all have b to the x. All a's are equal to 1, but they differ with the value of d. d here is 0. In the second equation, it is negative 1, and in the third, it is positive 1. So let's see how their graphs and even table of values differ. So this is the table of values for the first equation. The second is the table of values for f of x equals 2 to the x minus 1. So from 2 to the x, you'll just subtract 1. So 1/8 minus 1 is negative 7 over 8. 1/4 minus 1 is negative 3/4. Or you may also simply substitute each x value to x and solve for 2 to the x minus 1. And then the third table of values is for the third equation, f of x equals 2 to the x plus 1. So you may just simply add 1 to every 2 to the x. So 1/8 plus 1 is 9/8 and so forth. These are the graphs of the three equations in the example. The green is the graph of f of x equals 2 to the x, and then when we subtract 1 from it, we'll form the purple curve. However, if you add 1 to it, f of x equals 2 to the x plus 1, you'll form the blue curve. The properties of the graph of f of x equals b to the x plus d, so this is the variable here. First, the graph is increasing. So each of these three is increasing from left to right. Next, the graph is vertically shifted version of the graph of f of x equals b to the x by d units upward if d is greater than 0, and d units downward if d is less than 0. So from the graph of f of x equals b to the x, when you add 1 to it, or that is if d is greater than 0, this is positive 1 here, d is equal to positive 1, so that's greater than 0, the green graph, will be shifted vertically upward by the units by 1 unit, or by 1 unit. That's why from 0, 1, the corresponding point becomes 0, 2. From 1, 2, the corresponding point becomes 1, 3. Because the value of d is 1. So you will move the graph by 1 unit upward. And then since the value of d here is negative 1, then from green, we'll move each of the points 1 unit downward. So from 1 here, from 0, 1, it becomes 0, 0. From 1, 2, it becomes 1, 1. So that is one of the properties if the changes. Third is the domain, which is a set of real numbers. So x may take any value, negative, 0, or positive. The range or the set of y values is y is greater than d. The d always acts as the asymptote. So the range or the y values cannot be less than the value of d. So it is always greater than d. For the blue equation, the range is y is greater than 1 because that's the value of d. For green, it's y is greater than 0 or set of positive real numbers. For purple, it's y is greater than, what's the value of d? Negative 1. So y is greater than negative 1. So we can expect that it cannot be less than negative 1, nor it cannot be equal to negative 1. Next, y-intercept is vertically translated from y-intercept of f of x equals b to the x. So again, from 1 being the y-intercept of f of x equals 2 to the x, it is translated 1 unit upward because the value of d is positive 1. So it becomes 2. And here, since the value of d is negative 1, it will be translated 1 unit downward. So it becomes 0. And each of the graphs passes both the vertical and horizontal line tests. Example 5. Sketch and compare the graphs of f of x equals 2 to the x, f of x equals 2 to the x minus 1, and f of x equals 2 to the x plus 1. All a's are equal to 1. All b's are equal to 2. All d's are equal to 0. So what's different? The value of c. The exponent here is x. The exponent in the second equation is x minus 1. In the third, it's x plus 1. Again, the first is the table of values for f of x equals 2 to the x. The second is for f of x equals 2 to the x minus 1. So substitute each of x values to x and then solve for 2 to the x minus 1. For example, if x is 1, then this will become 1 minus 1 or 0. 2 to the 0. Any number raised to 0 power is equal to 1. So the corresponding value of y is 1. Then the third table is for f of x equals 2 to the x plus 1. So if x is 3, that will become 3 plus 1 or 4. 2 to the 4th is 16. Let us see their graphs in the next slide. So these are the graphs of the equations in the example. The green curve is the graph of f of x equals 2 to the x. The blue curve is of f of x equals 2 to the x plus 1. And then the purple curve is a graph of f of x equals 2 to the x minus 1. What are the properties of the graph of f of x equals b to the x minus c? C being the variable. First, the graph is increasing. So all these graphs are increasing from left to right. Second, the graph is a horizontally shifted version of the graph of f of x equals b to the x by c units to the right if c is less than 0 and c units to the left if c is greater than 0. That is why from the green curve, the graph is horizontally shifted to the left, since the value of c is greater than 0. It's positive 1. To the left, it is shifted to the left by 1 unit. The number of units is determined by the value of c. Since it is positive 1, then it will be shifted 1 unit to the left. For the purple curve, for 2 to the x minus 1 equals f of x, since the value of c is less than 0, then its graph, the green curve, will be shifted to the right. By how many units? Since c is 1, then by 1 unit. Next, the domain or set of x values is the set of real numbers. So it can extend any negative x value or any positive x value. The range or set of y values is the set of positive real numbers. Because y equals 0 or x-axis is an asymptote, the curve only gets nearer and nearer to it as x decrease in value, but it will not touch or reach 0. It cannot also be a negative number. The y-intercept is solved by substituting 0 to x and solving for y value. So the ordinary way of solving for the y-intercept, just substitute 0 to x and then solve for the y value. Substitute 0 to this x. 0 minus 1 is negative 1. 2 to the negative 1 is 1 half. So that will be the y-intercept. That's why the purple curve touches the y-axis at 1 half. And each of the graphs passes both vertical and horizontal line tests.
This lesson is best learned not by memorization, but by understanding the concepts. So let's have a quick review. On reflection, the graph of f of x equals b to the negative x is the reflection of f of x equals b to the x about the y-axis. And the graph of f of x equals negative b to the x is the reflection of f of x equals b to the x about the x-axis. On stretching and shrinking, the graph of f of x equals a times b to the x is the stretch graph of f of x equals b to the x if a is greater than 1 and shrink if a is less than 1. On vertical shift, the graph of f of x equals b to the x plus d is the vertically shifted version of the graph of f of x equals b to the x. That is, d units upward if d is greater than 0 and d units downward if d is less than 0. On horizontal shift, the graph of f of x equals b to the x minus c is the horizontally shifted version of the graph of f of x equals b to the x, That is, C units to the right if C is less than 0, and C units to the left if C is greater than 0. You may repeat the video, not to memorize it, but to understand it better. It's understanding the concepts. It's the